Hi everybody, we're going to use the complementary angle theorem. The complementary angle theorem merely states that cofunctions of complementary angles are equal. This is just an introduction. In the next two videos I'll do more specific examples. I'll do a few examples here. But basically we have a right triangle. Complementary means 90 degrees. So we're going to look at sine of beta and cosine of beta. If we look at sine of beta, we know sine is opposite. So in this case, my opposite of beta is b. So we get b over my hypotenuse. Well, this actually equals cosine, let me put it in black, cosine of alpha. Because cosine of alpha is adjacent over c, so that would be b over c. So they're the same value. And similarly, cosine of beta is going to be a over c, which actually equals sine of alpha. So these are cofunctions. Sine and cosine are cofunctions. And we can do the same thing with tan and cotan. Tan of beta is opposite over adjacent, which is going to be b over a. And this equals cotan of alpha. And the same thing happens with cotan. You just flip the a and the b. And that's going to give you tan of alpha. So these two are cofunctions because you get the same value. And the same thing with cosecant. Cosecant of beta is c over b, which is secant of alpha. And secant of beta is, you just flip these, you get c over a, which equals cosecant of alpha. So these are cofunctions because these two values are the same. So let's look at some examples real quick. I have sine of 30 degrees equals cosine of 60 degrees. So basically, these are the complementary angles. The green is complementary angles. And the cofunctions are sine and cosine. So let's do another one. And we know that this is true. You know from your unit circle that sine of 30 is 1/2. And we know that cosine of 60 is 1/2. So we can actually prove this one. Let's do some that we don't know very well. We have tan of 40. So that's going to equal cotan of 50. So again, here's your complementary angles, and here are your cofunctions. And we do one more here. We have secant of 80 degrees equals cosecant of 20 degrees. These are your complementary angles, and these are your cofunctions. Okay? We're going to quickly use the complementary angle theorem now. We want to know, by using it, let's look at sine of 62. So to change it to cosine, what we're going to do, it's a cofunction. We're going to take cosine and subtract 62 degrees from 90. And this is going to equal cosine of 28 degrees. Okay, and the next one, let's do something in radians. We have tan of pi over 12, and we know that that's our cofunction's cotan. So we're going to take 90, which is pi over 2, minus pi over 12. We get the common denominator. So that's going to end up being cotan of 5 pi over 12. And the last one, let's do degrees again. If we have something like sine squared of 40 degrees plus sine squared of 50 degrees, what I want to do is I want to change either this one or this one to cosine. If I change, let's say change this one to cosine, then that's going to be sine squared. I keep this one the same. And this is going to be cosine of 90 minus 50. So that's sine squared of 40 plus cosine squared of 40. And you know by your Pythagorean identities that this equals 1. Alright, or you could have changed this one to cosine squared by doing cosine squared of 90 minus 40 plus sine, and I'm just copying this one down now, sine squared of 50. So this is going to be cosine squared of 50 degrees plus sine squared of 50 degrees equals 1. Now this set right here is what I'm going to do in the next two videos. We're going to do much more complicated problems using the complementary angle theorem. Thank you and have a nice day. Bye-bye.